Let's go through a quick introduction about biomass. What is biomass? Biomass is a type of organic materials came from plants or animals. It is also one of the known sources of renewable energy on Earth. It can be converted to various types of energy form through combustion or biochemical conversion. It also contributes 10% to the global energy demand. Some type of energy that can be produced by biomass are heat, electricity, and biofuels. So why use biomass, you may ask? Biomass is one of the most practical and sustainable renewable energy to produce massively. It also helps increase the rate of local organic waste reduction. Compared to other energy sources such as solar and wind energy, it is more reliable and flexible. It is also environmental friendly energy to produce.
So this is our process flow diagram by using the AutoCAD, and there are different streams that are represented by different color of the line, which is the biomass solid stream, water stream in vapor state, water stream in liquid state. And there are different equipment that we use, which is firstly the biomass storage tank, boiler, ash storage tank, water feed and storage tank, a pump, cooling tower, condenser, steam turbine, and a generator. And after condensing, the pressure will be 75 kilopascal, and after pumping, it will be pumped to 8 megapascal, and after boiling, the water will be in 8 megapascal with 500 degrees Celsius. And in the boiler, there will be Q in, and there will be W in to the pump, and W out from the steam turbine, and Q out from the condenser. To convert the biomass to energy, fluidized circulated bed boiler FCB is used. And how it works. So, biomass fed to the FCB acts as fuels and ignites when contact with the bed. Combustion bed contain heated limestone or sand are in fluidized motion created by primary airflow. The fluidized bed burns fuel producing gases and solid products, which is the ashes. Combustion product like hot gases goes through a separate airflow pipe above, while the ashes are stuck below the fluidized bed and will be released to the ash tank. Hot gases transfer heat to the insulated water stream, producing steam that will go to the turbine. Cyclone pulls solid material to recycle and will be cooled at heat exchanger before recombustion to regulate the temperature.
The steam turbine will convert thermal energy into mechanical energy by rotating the rotor. First, it will heat the water until it turns into the steam. The pressure from the steam will push the blade, and the spinning reaction is what we call mechanical energy. So the generator will convert mechanical energy from the rotor into the electrical energy. So what happens is rotor will turn, and then the wire will spin inside a fixed magnet that we call stator. And then there will be a change in magnetic field, which allows the electron to move along the wire, and then that's when the electric energy generates. So the condenser will turn back the steam from the turbine into the water. So it actually make a closed loop system so that the water can be used again to make a heat. So what happens is the cold water in the pipe will absorb the heat from the steam, and then the steam will condense back into the water. Cooling tower will cool back the water from the condenser. So cooling tower has open valves that will allow the water to fall naturally into the tower basin. So the false water will warm up the air around it. The warm air will flow up, and then the air will go through the false water, and then the water is cooled back through the natural evaporation.
Okay, so for the thermal efficiency calculation, this is a simple visualization of the ranking cycle that we extract from the previous process flow diagram. So for stage 1, which is from the condenser to the pump, it's given that it is in a saturated liquid at pressure 1, which is 75 kilopascal. So we can find the temperature, specific volume, enthalpy and entropy based on table A5. So for stage 2, it's given that it is in 8 megapascal. So since it is an isentropic process, so we can confirm that S2 is equal to S1 and it is a compressed liquid. And by using the formula W in is equal to specific volume 1 times with delta P, we can get the W in, and from W in, we can get enthalpy 2 by using the equation H2 is equal to H1 plus W in. In stage 3, which is from the boiler to the turbine, it's given that the temperature is 500 degrees Celsius, and we know that the pressure in stage 3 is equal to the pressure in stage 2, which is 8 megapascal. Thus, we can know that in stage 3, this is a superheated vapor state. And according to table A6, we can obtain the value of enthalpy and entropy in stage 3. And in stage 4, which is from the turbine to the condenser, since this is an isentropic process from stage 3 to stage 4, so they have the same value of entropy. And we know that in stage 4, the value of the pressure is same as the value of the pressure in stage 1, which is 75 kilopascal. Thus, by comparing the value of pressure and the value of entropy, we know that in stage 4, this is in a saturated mixture state. So before we find the H4, which is the enthalpy in stage 4, we need to find the quality first. So by using the value of entropy, we can get the quality, and by substituting the value of quality, we can obtain H4. So to find the thermal efficiency, we need to find the Q in and the Q out. So for the Q in, which is H3 minus H2, and for the Q out is H4 minus H1. So by substituting the Q in and Q out into the formula of thermal efficiency, which is 1 minus Q out over Q in, we can get the thermal efficiency is 0.3309, and in percentage form, 33.09%. And to find the value of W out, which is the work out, we need to assume the mass flow rate is 250 kilo per second. Thus, we can get the W out is 250.788 megawatt. Below it, this is the TS diagram of our process.
For the thermal efficiency, JIMA is achieve the efficiency around 35 until 40%. For FCB, the thermal efficiency that we achieve is 33.09%, lower than JIMA. And then for Nova Energy, they achieve efficiency around 20 until 35%. And for the capacity, JIMA is produce capacity about 100 megawatt until 1000 megawatt, while FCB is produce capacity about 250.788 megawatt. And for Nova Energy, they only produce capacity about 40 until 45 megawatt, which is lower than FCB and JIMA.
So the alternative fuel for JIMA coal plant is they are considering ammonia biomass co-firing in their coal plant. So some trials were executed on September 2023 using empty fruit bunches. The main objective of this is to reduce the carbon emission. And then go back to our power plant. We are considering municipal solid waste because it can reduce the harmful material, can prevent the corrosion and also cooling of the boiler. And then the bottom ash will also contain some valuable materials such as minerals and also glass. So this will increase the rate of metals recovered per kilogram. And then for the Nova Energy power plant, silicon was known as earth-based materials that will convert sunlight into the electrical energy through the photovoltaic effect. Also, silicon offer a very low price. And then some of them also use emerging technology that using a man-made substance such as perovskite. The environmental effect of JIMA's power plant is that it has an electrostatic precipitators to capture metals such as dust and also ash before it is released into the air. And then it was also installed with a flue gas desulfurization, which will help to remove sulfur dioxide so that we can reduce the acid rain formation. But the bad impact is that it will emit 75% more CO2 per megawatt hour than a modern ultra supercritical plants that will contribute to a climate change. And then for our plant will help in reducing waste. Hence, overburning and also land disposal can also be prevented. While this other environmental effect that the greenhouse effect was also reduced since this method will prevent the biomass decomposition that will emit the methane gas. So that our way is that we handling the ash safely by storing it in a tank so that we can prevent the dust pollution and even recycling it for cement or also fertilizer. But our fuel combustion can cause air pollution by emits the carbon monoxide and also sulfur oxides and nitrogen oxides into the air. For the Nova Energy, the environmental effect is that the carbon footprint emission reduced by 10 to 50 orders of magnitude lower than the emission from the burning of oil. But the bad impact is that the manufacturing process includes a number of hazardous materials that are used to clean and purify the semiconductor in this plant. And then the other bad impact is that a bad handling of these photovoltaic films could pose a serious environmental issues.
So the process cycle involved in the JIMA power plant and ours is the Rankine cycle, since it involves a flow stream going in a cycle through four main components, which is pump, condenser, turbine and boiler. While the Nova power plant uses grid-connected solar photovoltaic system where the solar power system is connected directly to the electricity grid for immediate energy conversion. For the fuel sources, the JIMA power plant uses pulverized coal where the coals are crushed into powder before being burned and uses diesel as process startup fuel. Our power plant uses biomass since it is the most suitable green energy that can be produced compared to coal fuel. The Nova power plant, on the other hand, uses solar radiation as energy source for their plant.